Hello kids. So in today's class we are going to start with the new topic palindromic patterns. Okay. So to start with I'll tell you what are the palindromes. So basically these are the numbers and which can be read same from the right or the left side. Example is your ring number like 88. If you start reading from here, if you start reading from right side, it is 88. If you are starting reading from here also, then left to right, right to left, it is same 88 here. Similarly, if I take any number 171, okay, so if you start reading from this side, it is 171. If you start reading from this side also, then again it is 171. Similarly, I have 252. From here it is 252. If you start reading from this side also, this is 252. So these are called as the palindromes or palindromic numbers. So let us see what is written here. What pattern do you observe in these numbers? 66, 848, 575, 797 and 1111. So these numbers read the same from left to right and from right to left. If you start reading from this side or this side, the number would be same. Try and see. Such numbers, they are called palindromes or palindromic numbers. Okay. And then what is given to us here is all palindromes using 1, 2 and 3. The numbers are 121, 313, 212. What they have done here is they are using only 3 numbers and they are trying to make few palindromic numbers from this. What they have made is 121, 313, 222. They are some examples of the palindrome using the digits 1, 2 and 3. This is what they have done. Now, the question given to us is write all possible 3-digit palindromes using these digits. So, again, we are given the same digits 1, 2 and 3. And what we have to do is we have to write down all the possible palindromes using 1, 2, 3. So, I'm writing the answer here. This is very easy. All palindromes using 1, 2 and 3. So, let's start with 1 first. So, we will have 1, 1 and 1, first one. Then we have 1, 2 and 1, 1, 3, 1. Okay. Next, 2, 1, 2, 2, 2, 2. And then we have 2, 3, 2. With 2 we have done. Now with 3, it is 3, 1, 3, 3, 2, 3, 3, 3 and 3. So these are the numbers we are getting using 1, 2, 3 and all these numbers are the palindromes. See, if we read these number from any side, here or here, the number is same 111, 121 or from here also 121. Similarly 232 from here and 232 from this side as well. 323, 313. So we read these numbers from any side, the number is same. All these numbers are palindrome numbers. Now, next is reverse and add palindromes. So this is one activity. What they have done is now look at these additions. So these are certain additions given to us. Try to figure out what is happening. Okay. So what they have done is they have taken one number 34. Okay. And then they have reversed this number. The reverse of 34 is 43. And then they have added these two. They have added the number and its reverse. And the answer which we are getting here is a palindrome number, which is 77. Okay. So this is a palindrome number. Next, they have taken another example of 29. They have taken the number 29. They are reversing it and getting 92. And when they are adding it, we are getting 121, which is again a palindrome number. So the steps they are following is, first of all, they are taking one number and then they are adding the reverse of that number to it. The addition will give us a palindrome. But now in the third case, the addition of 48 and its reverse 84 is not giving us a palindrome. It is giving us this number 132, which is not a palindrome number. So if the number we are getting from the addition is not a palindrome number, they are again taking the reverse of that addition. So the addition was 132 and now they are taking the reverse of this addition, which is 231. And again the same step, they are adding that addition, and this time we are getting a palindrome number. Okay, so the steps to follow are written here is start with the 2-digit number. So we have to start with the 2-digit number, add this number to get it reverse. Stop if you get a palindrome. So if you get a palindrome, this is into it. Or else if it is not, we are not getting a palindrome after addition, like in this particular scenario, repeat the steps of reversing the digits and adding. So we have to reverse the addition, the addition, and then we have to again add it, and this time we will get a palindrome number. And if again we are not getting, again we have to repeat the process. So try the same procedure for some numbers, and if perform the same steps, and stop if you get a palindrome. Now there are numbers for which you will have to repeat this process a number of times, a large number of times. So there might be few numbers. Then, are there numbers for which you do not reach a palindrome at all? So, this answer is given to us in the book itself, that yes, there are certain numbers like 196 is one of the number for which we are not getting palindrome till the how many times we added. We are not getting a palindrome for this number. Now, the question given to us is, will reversing and adding the numbers repeatedly starting with a 2-digit number always gives a palindrome? Explore and find out why. So, not always, exception to it is 196, but let us try with few other numbers also and see how it is working. So, answer of this question is, example, I'm taking any number, let's say, let's take 56. I'm taking 56, and then I am reversing this to 65, and then I am adding it. 6 plus 5 is 11. 6 plus 5 is 11, plus this one is 121, which is a palindrome number. Okay, so this is one thing which we have done here. We can take another example also. Let us take a number, let us take 93. So 93 plus its reverse, it is 9 plus 3 12, and then this is 13. 9 plus 1 10 plus 3 13. This one is not a palindrome number. So what we'll do, we will take its reverse. So I'm adding 2 3 1, which is reverse of this number, and this time this is 3, this is 6, and this is 3, which is a palindrome. Okay, so yes, we get the palindrome number most of the time, but with some exceptions like 196 where we are not getting it. Now we have a puzzle time given. Okay, let us see what is there in it. Okay, so I am a 5-digit palindrome. This is a 5-digit palindrome number given to us. Okay, and I am a odd number. Also mentioned here is that it's a odd number. My 10th digit, means this digit, is double of my unit digit, the one at ones place. So this is twice which is present here. And my H digit, the 100 digit, is double of my 10 digit. This is double of this. Now we have to find what is this number. So kids, first of all, if the number is a palindrome number, and it's a 5-digit number, that means this digit should be same as this one, and this 10,000 should be same as this one number. Okay, this will be the constant or the number from which will be same in both the case. Okay, so this is one thing which we understood if it is a 5-digit palindrome number. Now start, and also it is given as an odd number. The number which is given to us is odd. Now let's try doing this. I am taking this unit digit as 1. Let's take this as 1. So if this is 1, my 10 digit is double of my unit digit, means this will become twice of 1, which is 2. And my 100 digit is double of my 10 digit, and this will become 4. Who am I? So if this is 4, 2 and 1, this number and this number will be same. This number and this number will be same. So we have 1, 421 as the answer of this puzzle. This is the palindrome, 5-digit palindrome number. Okay, so this is very easy. I hope this is clear to you, kids. Since this was a very small exercise, let us pick up the next exercise also, which is the magic number of Kaprekar. So Dr. Kaprekar was a mathematics or a teacher in government school in Devlali, Maharashtra. He liked to playing with numbers and he find out very beautiful patterns. Okay, so in 1949, he discovered a fascinating and magical phenomena when playing with a 4-digit number. So let's see what he has done. Follow these steps and experience the magic for yourself. Pick any 4-digit number. So he has taken any 4-digit number having at least 2 different digits. So the number should have at least 2 different digits. Okay. So they have taken a 4-digit number. Now make the largest number using the 4-digit number and call it A. Okay. And now using the same 4-digit number, make the smallest number and call it B. Okay, so what we have done, we have taken a 4-digit number. Like in this case, they have taken 6382 as the number. And first, they are identifying the largest number. So kids, we know that we have to make any largest number from the given digit. What we will do, we will arrange the digits in the descending order. Okay, so it will be 8632. So for A, the largest number they have taken from this 4-digit is 8632. And smallest digits, for smallest digit, we will arrange the number in the ascending order. So it will be 2368. So we have taken 2368 here. We have the two numbers. We are calling the largest number as A and smallest number as B. Now, the third step tells us subtract B from A and call it C. Now we have to take a difference of these two, and the difference is we are calling this difference as C here, which is 6264. Okay, this is what we are doing here. Now, when we are doing these things, what it is saying us is, wait, I'm moving further to it. Take the different 4-digit numbers and try carrying out these steps. Find out what happens. Check with your friends. You will always reach the magic number 6174, and the number is called as the Kaprekar constant. So what it is saying is that when we will find out the difference, it will always be 6174. Carry out the same steps with a few 3-digit number, and what number will start repeating, we will see. Okay kids, so coming back here, what we have done, we took one number and we have find out the difference. It was 6264. So since it was 6264, again this is the new number for us. We will take the largest number, we will call it as A. We will take the smallest number from this, we are calling it as B, and we are again finding the difference here. So this is the first time we are doing this. We are second time we are doing this. First time, second time, 4176 is the answer of subtraction here. And then again for the third time, what we are doing here is we are again taking the biggest number here, smallest number here, the difference. And the difference we are getting here is 6174. So what this flow chart, what does it define to us is, see here, come back, I'm going back to the flow chart, that we have to take a 4-digit number, any digit number, we should have at least 2 different digits. It should have at least 2 different digits. We are taking the biggest and the smallest number and finding the difference. If the answer here is 6174, which will eventually come, okay, then that is the end to it. If not, then again we have to repeat the same process with the subtract the answer which we have got here. Okay, this thing. So let us do this question, and we have been asked to carry out the same thing with some 3-digit number, and that how it is repeating. We have to see this. Okay, so in this case, we have to take a 4-digit number. So let us take the number 1, 2, 3, 4. Okay, I'm taking this number 1, 2, 3, 4, and we will take the maximum of this number, which is 4321, the largest number, and the smallest number which we can make here is, I will make it as B, it will be 1, 2, 3, 4. So what we have done, we are taking the number 1, 2, 3, 4 and we are finding out the largest of this number, which is 4321, and the smallest number from this, which is 1, 2, 3, 4. And now what we have to do is, we have to find the difference. This is 11 minus 4 is 7. Again, 11 minus 3 is 8. This is 0. 4 minus 1 is 3. So certainly this is not the Kaprekar constant 6174. So what we will do next? We will again take this number 3087, and now from this we will find the biggest number. The biggest number will be 8730, and the smallest number, which will be 378. And now let us find the difference. This is 10 minus 8, 2, 12 minus 7, 5, 6 minus 3 is 3, and 8. Again, this is not a Kaprekar constant, so we will have to again repeat the steps. We have 8352 as the number. Now let us find the largest number from this, which will be 8532, and the smallest number here, it will be 2, 3, 5 and 8. And now let us find out the difference, which is 12 minus 8 is 4, 12 minus 8 is 4, 12 minus 5 is 7, 4 minus 3 is 1, and then we have 7 minus 2, which is, sorry, not 7. Yeah. So here we have 8 minus 2, which is 6. 6174, and this is the Kaprekar constant. So we have seen, we have repeated the same process. We took a number 1, 2, 3, 4, find out the largest and the smallest of it and the difference, which was not Kaprekar, and we repeated the process 3 times here, and finally we got the Kaprekar constant. Okay, so this is what we were intending to do in this question. So kids, this is the end of this exercise, and in next class we will start with the topic 3.7. Okay, so I will see you all in the next class now.